Welcome to Two Projects. In this video, we are going to explain about the project that is a suicidal ideation detection framework on social media using machine learning and genetic algorithms. Before getting into the execution, first let us understand what is the project about. Mental health, which is an pressing issue, that is important issue, which affects millions of people around the world and its impact is far reaching. The World Bank reports that about 10% of the global population struggles with this mental health challenges. And one of the most devastating consequences of this issue is the suicide. Suicide, it claims around 8 lakhs lives each year and it is fourth leading cause of death among individuals of the aged 15 to 29 according to World Health Organization. What makes this issue more complicated is that many individuals who experience suicidal thoughts don't always feel comfortable discussing their struggles face to face. However, with the rise of social media platforms like Reddit, Twitter, Facebook, people have found a space where they can express their emotions more freely and anonymously. This anonymity is crucial because it allows individuals to open up in ways they might not in a person. For researchers, for researchers, this creates a unique opportunity to analyze the text shared on these platforms. So, by examining the language, emotions, and behaviors expressed in these posts, we can identify potential risk factors and early signs of suicidal ideation. This analysis can provide valuable insights that could lead to timely interventions, possibly preventing suicide and saving lives. When it comes to detecting suicidal thoughts from social media posts, the current methods that we have some real limitations. So we have some real limitations of those old methods. For instance, many existing approaches relies basic text classifications like bag of words, which fails. I mean, while these methods they can look at the words used in the post, they don't truly understand the deeper meaning or the context behind them. This means they often miss out the subtle emotions or underlying messages that could point the suicidal ideation. On top of that, on top of that, the data we work with often has lot of irrelevant or repetitive features. These unnecessary details can actually hurt the performance of the predictive models, making them less accurate. To really make a difference in detecting suicidal thoughts, we need to go beyond these basic methods. We have to find a ways to capture true meaning behind the words, eliminate irrelevant features, and focus on the important details that can help us to identify risk early on. This would ultimately allow us to intervene in a timely manner and potentially save lives. So, the idea behind this project is to detect the suicidal thoughts on social media, which is more effective by focusing on the most important features of the post. One of the key problems with earlier methods is that they often use too many unnecessary features, which can confuse the model and make it less accurate. This system solves that by using advanced techniques to extract only features that truly matter, those that give us real insights into the person's emotions and state of mind. And here in this project, we are using the dataset that is taken from the Kaggle, which includes posts from Suicide Watch and Depression subreddits on Reddit. These subreddit features discussions on mental health struggles, including suicidal thoughts, make them ideal for training a system to detect suicidal ideation. By analyzing this real world data, the system can identify patterns in how people express their distress online. To make sure that we are picking out the best features, the system uses genetic algorithm. So we use genetic algorithm to extract the important features. Think of it like a smart filter that helps us to choose the most relevant and important details for classification. This way, the system doesn't get bogged down by any irrelevant information and it can focus on what is really important for identifying suicidal ideation. Ultimately, this approach improves the system's accuracy and making it more effective at detecting at risk individuals. To make the detection process even more accurate, the system uses several powerful machine learning algorithms that are random forest naive Bayes gradient boosting and XGBoost. Each of these classifiers has its strengths, and by combining them, the system becomes more reliable in identifying suicidal ideation. The focus isn't just on the words in a post, but also on how they are used. which helps us to capture the deeper emotional meaning behind the language. This means the system can pick up one on subtle emotion signals that might indicate someone is at risk, like feelings of hopelessness or distress, and even if they aren't directly mentioned. By taking into account both the context and the emotions behind the words, it offers a more efficient and dependable way of recognizing when someone may need help based on their online behavior. Moving on to the extension part, here as an extension, we are using an ensemble model called voting classifier, which is a clever way of combining predictions from several different models. Think of it like getting the opinion of multiple experts instead of just one. By doing this, the system becomes more reliable and accurate in making predictions, as it benefits from the strengths of individual model. Additionally, in this project, we are building front end using Flask framework. So this would allow users to interact with the system easily, making it more accessible. With the front end, we have also integrated user authentication mechanism, which ensures that only authorized users can access the system, making the whole process secure and private. Moving on to the implementation of the project. To implement this project, we have followed the steps of the flow of work. Let us understand what are the steps that we have followed. The first steps comes to the data collection and pre-processing. So first, we start by collecting a data set from social media, which includes posts that have been labeled either as suicide or non-suicide. These label helps us to distinguish between posts indicating suicidal ideation and those that don't. Once we have the data, we move on to cleaning part. So this means we remove unnecessary parts of the text such as common stop words like the, and, etc. Punctuations and the other elements that don't add meaning to the prediction. We then extract features from the text using TF-IDF, that is term frequency, inverse documents frequency, and n-grams, which helps us to capture the important words and phrases in the post. Then comes the feature selection part. In this step, we apply genetic algorithm to select the most relevant features from the data. Genetic algorithm helps us to identify which features are truly important for predicting suicidal ideation, while eliminating irrelevant ones. This reduces the complexity of the data, making the system more efficient and focused on the most critical information. Then comes the data splitting part. Once we have our data set and selected features, we split the data into two parts. The training set is of 80% and the testing set is of 20%. Training set is used to teach the machine learning model how to recognize suicidal ideation, while the testing set will help us to evaluate how will the model perform on new unseen data. Then comes the algorithm training part. Now we train multiple machine learning algorithms using the features selected through genetic algorithm. These algorithms like random forest, naive Bayes, and others learn from the training data and figure out how to distinguish between posts that indicate suicidal ideation and those that don't. The goal is to create models that can make accurate predictions based on patterns they learn. Then comes the model evaluation. Once the models are trained, we evaluate their performance. This step involves using various metrics like confusion matrix, accuracy, precision, recall, and FN score to measure how well each model is identifying the suicidal ideation. Then comes the testing and prediction. After we evaluate the models, we test them on the new unseen data. This is where the application comes in. Once the model is tested, it is used to predict whether a new post indicates suicidal ideation or not. This helps us to ensure that model can generalize to new data and make real world predictions. And here comes the front end part. To make the system more user friendly, a front end is developed using Flask framework that provides a simple web interface that users can interact with the model. The front end allows users to input the text and it ensures that system can be easy to use and accessible. And in the front end, users they will be able to provide a text post through a web interface. This text is what the system will analyze to determine whether it indicates suicidal ideation or not. Once the user submit the text, the system pre-processes the input. This step involves cleaning and preparing the text in the same way we did in the dataset, removing stop words, punctuations, and other unnecessary elements to ensure the model can analyze text. Then comes the part that is train model is used for the prediction. So the given input will be pre-processed, I mean, it will be fed with the train model for the prediction purpose. And then we will be getting the output. So finally, the pre-processed text is fed to the train machine learning model, which makes a prediction about whether the post contains suicidal ideation or not. This prediction is based on the patterns that the model learned during training, and the result is displayed to the user through the front end of the application. Moving on to the algorithms used, these are the algorithms that are used to train the model so that they will be able to classify whether the post that is a text is suicidal or not. It is a suicidal text or not. So here, if you observe, we have trained each model, that is random forest model, with the original genetic algorithm features and linguistic genetic algorithm features. Let us understand what is the difference between this. Coming to original genetic features, these features are directly based on the text structural aspects, as the word patterns, frequency, or statistical properties. On the other hand, what does linguistic genetic algorithm features? These focus on the meaning and also the context of the word, which captures the semantic and emotional nuances. While original features provide a basic representation, linguistic features delve deeper into the intent and sentiment behind the text, making them more insightful for understanding suicidal ideation. So each algorithm we have trained it with original genetic algorithm features and linguistic genetic algorithm features. And here we have KNN algorithm, gradient boosting, XGBoost, and extension voting classifier. To implement this project, we need hardware and software requirements. Coming to hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. And coming to software requirements, we need application of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So these are the source code files in the code folder of the project. Now let us understand and then execute. So let's open the dataset folder first. Here we have the dataset that is used in this project. Let us open it. So here we have the dataset that is used to train the models for detecting the suicides and non-suicidal text. So here we have total 2,32,137 text, respective class labels too we have, where this text belongs to suicide and this text belongs to non-suicide. Similarly, for all the 12 lakh thousand plus text, we have all the class labels too. Now let's close this. And here in this test data, we have the test cases that we will be using in the front end for predicting whether the text belongs to suicidal case or non-suicidal case. Let's minimize it. Let's get back. And here in this model folder, we have the algorithm information that will be loaded into the project code during runtime of the application. And here in the static folder, we have files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. Coming to the templates folder, this folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this app.py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have signup.db file. This is the database file which is used to store the user information. And this is the notebook file. This is a Jupyter notebook file, which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. Now we have understood all the files. Now let's execute. So copy the path. We need to copy the path of the code folder from the address bar of the file explorer. So copy the path, copy it. Now open the command prompt. Here it has been opened. Now give the command cd, give the space and paste the path which we have copied just now. And now click on enter. If you observe here, current directory is changed to the code folders path. Now we are supposed to compile the app.py file. So give the command python space app.py. And now click on enter. So here, by executing this command, it will execute Python script and perform an runtime check for any syntax errors or logical issues. And after running this app.py, Flask framework will host the application locally at the default address, which is the local host and the port, unless configured differently. So just wait for a while where localhost will be generated. Here localhost has been generated. This is the localhost and this is the port. Now copy this local link provided by the Flask framework and paste it in any web browser. I've copied it. I prefer Google Chrome, so I will paste it in that. Paste the link here. Click on enter. This is the web page of the project, which is displayed in the browser. So now we are supposed to sign up. Click on sign up and enter all the registration details if you are registering newly. I have already registered, so I will directly sign in. Click on sign in. Here you're supposed to provide your username and the password. So I'm giving my username and the password. Now click on login. You have logged in successfully and you are redirected to prediction page of the project. So here you can see a choose file button, right? We need to click on that for uploading the file, text file. So click on choose file. Here in the dataset folder, we have the test cases. We are supposed to upload this test data. Click on open, in which we have different text in it. Click on upload. So this given input, it will be pre-processed at the backend and then it will be fed to the trained model, and trained model will be giving us a prediction. So in the Excel file, this is the first text that we have. So this is the text and here it has predicted as suicide. So this text belong to the suicide class. And here we have the second text. So this is the second text. So this text also belongs to the suicide class. And here we have the third test case where it has been predicted as non-suicide. So it has predicted as non-suicide. Similarly, we have for all other cases also. Here, if you observe, for all the text that we have uploaded, we got the prediction where if it was suicide, here it has predicted as suicide. If it is not, it is predicting as non-suicide. Now let's check with the graphs. Click on graph. And here we got the graphs. So the first graph is the confusion matrix graph of the extension model, that is voting classifier. Here on x-axis we have the predicted class and on y-axis we have the true class. And this is the accuracy score. Here in this graph, on x-axis we have accuracy score and on y-axis we have all the algorithm names. These are the algorithms which are trained for classifying the suicide and non-suicide class. And this is the precision score comparison graph. This is the recall score comparison graph. And this is the F1 score comparison graph. These four are the metrics, that is accuracy, precision, recall, and F1 score are the metrics which are used to evaluate all the classification models. Now click on sign out. In this, which is by giving the input to the system, then it will predict whether the given input text is suicide text or non-suicide text. This will help us to prevent the suicidal this will help us to prevent the lives of the people who want to commit to suicide. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.